Good morning, students. We are going to discuss matter in our surroundings. We all know that matter is made up of particles, can be known as atoms. Those are invisible. And the matter can be existed in solids, liquid, gases. Matter can be available in solids, liquid, gases. And characteristics of particles of matter we are going to explain. What we are going to explain? The characteristics of particles of matter. The first one is particles of matter are continuously moving. See, whenever some amount of potassium permanganate is dropped into some water, how it is moving. And particles of matter have space. Of course, in gaseous more space, and liquids less space, and solids no space. And particles of matter attracts each other. The inside particles of matter attracts each other. Now, we are going to explain some property, changing of properties in the case of solids, liquid, gases. The first one is the force of attraction. The first one is the force of attraction. How it will be in solids, liquids, gases. In the case of solids, inside particles, force of attraction is more due to having less space between particles. But in the case of gaseous particles, there is less force of attraction because of more space occurs between particles inside. And finally, if you can observe the force of attraction in the case of solids, liquid, gases, solids more and gases less, and liquids intermediate in between solids and gases. And density. What is meant by density? We already know that the density definition, mass per unit volume, can be known as density. Density equal to m by v. Here one thing you have to mind it, more mass, more density, less mass, less density. Because of this property, solids are having a high mass. That's why more density took place for solids and less density took place for gases. And kinetic energy. What is meant by kinetic energy? Energy possessed, energy produced by virtue of motion. So energy is obtained because of motion of the object. When object is moving, it will get kinetic energy. And formula Ke equal to half mv square, whereas m is mass of the object and v is the velocity of the object. What is the formula? K equal to half mv square. So gases are having the particles inside gaseous particles having more kinetic energy because of having more space. In the case of solids, less. Compressibility. Compressibility is the process by increasing pressure, decreasing volume. Once again, compressibility is the process decreasing volume by increasing pressure. So see, more compressible, gaseous particles getting more compressible. Why? Because gaseous particles having more space compared to solid particles. Solid particles are having less space. So that gases are more compressible, whereas solids are less compressible due to gases are having more space between particles, solids are having less space between particles. And diffusion. What is meant by diffusion? Diffusion is a spreading sense. So any particle mixed with air particles and moving from the region of higher concentration to the region of lower concentration. Once again, the concerned particle mix with air particles and moving from the region of higher concentration to lower concentration. So gases are having more diffusion property and solids are having less diffusion property and liquids are intermediate. Rigidity is it is inability to change or adapt. In the case of solids, gases and liquids, the rigidity property more in solids and less in gases, whereas liquids intermediate, that is depends upon force of attraction. Solids force of attraction more. And lower classes you learned solids, liquid, gases, shapes and volumes. In the case of shape of substance, solids are having definite shape and liquid and gases are having indefinite shape. In the case of volume, solids having definite volume and liquids having definite volume, whereas gases are having indefinite volume. And liquid shape depends upon, it doesn't have any shape, it doesn't possess any shape, but shape of the container. Latent heat of fusion. In the case of latent heat of fusion, heat is given to the solid. Then what happens? Particles inside solids get vibrations and they will get kinetic energy. Once they will get kinetic energy, its temperature increases on particular level. Their temperature starts. There, the applying heat dominates the force of attraction between particles. Then, solid converting its state, that is liquid state. Here temperature is constant. Temperature is constant. Of course, for conversion of solid to liquid at constant temperature, the heat is given. The utilizing heat can be known as latent heat of fusion. Latent heat of fusion. Once again I am going to explain. Heat is given to the solid. Inside particles gets kinetic energy and temperature is also increases from up to one particular level. At a particular level what happens? Temperature should be constant and here the state of solid is converted into a liquid state. Here how much? Here the given heat, here the utilized heat can be called as latent heat of fusion. And moreover, I am going to explain this concept in the terms of graphical representation. X-axis and Y-axis. X-axis indicates applying heat and Y-axis temperature. For giving heat, for applying heat, for the solid substance, the temperature increases up to particular level. Here what happens in this particular stage? Solid is converting liquid. Here heat is utilized for conversion of state. at constant temperature. The temperature is constant. Of course, the constant temperature at this point can be called as melting point. This point can be called as melting point. Melting point is indication of force of attraction in the solids. Force of attraction between particles inside solid. Now latent heat of vaporization, another concept related to this lesson. So I have taken liquid. So heat is given to inside particles of liquid. What happens? Inside particles absorbs heat and gets vibration, and they will get kinetic energy. Once they will get kinetic energy, their temperature increases up to particular level, up to particular point. At point what happens? Temperature is constant. Here what happens? The liquid state of particles converts into gaseous state of particles. Of course, what happens? The force of attraction between particles less than of applying heat. That means applying heat dominates the force of attraction between inside particles. Then only conversion of state occurs, liquid to gases. Of course, it is called latent heat of vaporization. Heat is applied to the liquid. What happens? The inside particles absorb the heat and they will get kinetic energy, and temperature increases up to particular point. At particular point, temperature is suddenly stopped. The temperature should be constant. Why? Because here heat is utilized. Heat is applicable only for conversion of state, that is what, liquid to gases. Of course, this phenomenon is called latent heat of vaporization, and this can be explained in terms of graph. How we can explain? This is y-axis and this one is x-axis. X-axis, what I have given, heat, and y-axis, temperature. For the solid substance, the temperature increases up to particular point. At a particular point, what happens? Solid is converted into liquid. Once conversion of liquid, again temperature increases. And it reaches one particular point, then what happens? Liquid is converted into gases. So this is only solid state, temperature increases, yet temperature is constant. Here what happens? State changes, solid to liquid. After conversion of liquid, again temperature increases. Here what happens? Liquid is converted into gases. So both cases done at constant temperature. Temperature is constant. Here also temperature is constant. If temperature constant, the point can be called as melting point. Here point can be called as boiling point. Here heat is utilized to convert solid to liquid. This stage can be called as latent heat of fusion. Conversion of liquid to gases. This stage can be called as latent heat of vaporization. From video, self video, what you learn, latent heat of fusion. What is latent heat of fusion? At a constant temperature, heat is utilized to convert solid state of the particles to liquid state of the particles. Of course, the constant temperature can be called as a melting point. Next, latent heat of vaporization. What is latent heat of vaporization? At constant temperature, heat is utilized to convert liquid state of substance into gaseous state of substance. Of course, here constant temperature can be called as a boiling point. And see the graphs. Latent heat of fusion at constant temperature, latent heat of vaporization at constant temperature. So in graph x-axis, heat applied, and y-axis, temperature. Thank you. Next class, we will discuss sublimation, condensation, freezing, and Kelvin and Celsius temperature relation